my presentation will be about the products available through WEkEO from the Copernicus Atmosphere Monitoring Service. So you've already had an introduction from Gail on Copernicus, so the European Union's Earth Observation Programme, which includes a fleet of satellite constellations for monitoring the Earth system, but also there's a service component where we take this data and provide value-added services across the different sectors. So ECMWF is entrusted with two of these services, the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. And we also provide support to the Copernicus Emergency Management Service. And what we do is we provide open and free information products based on the satellite data and also in situ data. And this data includes, so the products we provide include past, current, and near future forecasts of global atmospheric composition and also reanalysis. We also provide information on the ozone layer, so stratospheric ozone as well as tropospheric ozone. We provide European air quality data, emissions and surface fluxes of key pollutants and greenhouse gases, also solar radiation time series, and global radiative forcing. So in the slide here, you see some example products from CAMS, and these are all available through WEkEO. And the way it operates is we take the data, and then we assimilate the data into our global model. So we have at ECMWF the integrated forecasting system, but we also have for regional air quality, European air quality, we manage a series of systems, different independent systems, and we provide the data from these as well. And on the right-hand side, you see some example products, some example forecasts from aerosol optical depth. And just to mention that we do have some direct users. So we have many people are taking this global and regional data and using it directly, but we provide, we have a specific role in the kind of data value chain. And what we do is we support downstream services to do further value adding on these products. So let's say, for example, you have an entity who wants to deliver a service using very high resolution data. So they want to provide high resolution information on air quality at the kind of municipal scale. Then what they can do is they can take the global data and they can do some downscaling, and then they provide a service to their own users. So basically, we purposefully do not provide super high resolution information products because there are other entities who can do that. So basically, we have people who are using our data directly, but we also have a lot of indirect users who are using value-added products from these other services. So there are entities, small companies developing, for example, mobile apps. We also provide data to different channels such as Google, news channels. So the data is very much visible and it's used, and it's also being disseminated to a very large number of users. And this slide here just shows the complexity of the process in terms of taking the satellite data, assimilating it into the models, and you see the difference. So in this very complex table here, on the left-hand side, you see the satellite instrument, and then you've got the sensor, sorry, the satellite platform, the sensor, and then you have the different species that it monitors. And we take the satellite data and we assimilate it into the CLAMS global system. It's only satellite data used. We use the in-situ data for verification and assimilation into the regional systems. And then, of course, what you don't see here is all the data that's used for the ECMWF numerical weather prediction assimilation system, which is a huge quantity of data. So here we're just talking about atmospheric composition. And this slide just shows you the added value of new missions that come along. So, for example, this shows the reduction in the relative carbon monoxide bias, having assimilated tropomi data into our system. So you just see here, for example, a series of charts where, especially in the kind of troposphere, you see a greatly reduced bias in CO after having assimilated tropomi data. So we're constantly improving the system when new instruments come along, and new data comes along, and we're improving the products for our end users. So the main purpose of this presentation is just to give you a flavor of the different information products that we provide. So, for example, we have forecast products, and forecast products of very many different variables in atmospheric composition. This is an example of CAM's total aerosol optical depth. So, you know, we provide forecasts for the global data 5 days ahead, every hour, 5 days ahead. But what you're seeing here is an animation of the analysis. So basically, it's taking the observations, assimilating them, and providing the best estimate of the current state. And this is done for multiple time steps. And then what you see in the charts are a comparison of the forecast data with data from AeroNet, from this network of ground-based remote sensing data. So that was total aerosol optical depth. And here's an example of SO2 from volcanic eruption, the Cumbre Vieja volcanic eruption on La Palma. And again, you see the comparison with AeroNet. And so in addition to the forecast, we also have reanalysis. So basically, we're taking all of the analysis time steps for past decades. And now we have over 20 years of reanalysis. So basically, reanalysis is filling in the gaps in space and time. So you have a consistent data set going back multiple decades, where you can really look at past trends that will give you an indication of you know, what the future may be like as well. So we have this reanalysis data, and there are different things you can do with this. So this is one example. You can really put events into context. So what you're seeing here on the top left, you see the climatology for January. So every January from 2003 to 2019 in this case. And on the top right hand side, you see the climatology for June. Okay, for every June for that whole period, and you see the average there. And then on the bottom, you see the anomaly with respect to that climatology for a particular year. So in this case, it's January 2020. And you see that there is January and June. So you see that, for example, there's a big dust event, which is much greater than the average. So that's actually the Godzilla dust event. But for the wildfire emissions, you actually see a lower than average emissions. Okay, so this is an interesting data set to put these kind of events into context, to see actually how significant was a particular event. So in addition to the forecast and analysis, the forecast and reanalysis data for atmospheric composition, we also have global wildfire emissions. So this is an animation here of fire radiative power. So this is taken from the satellite data. In addition to that, we also have various different emission products. So anthropogenic emissions for different sectors. We have shipping emissions, biogenic emissions, and this is all available through WEkEO. And just an example of what you can see with this data. So in 2023, that was actually a record year for Canadian wildfires. And you can really see how significant it was that year. So if you look at the chart on the top right, you see total wildfire emissions over the kind of wildfire season, and you can see that compared to previous years in the grey dotted lines. And then you also see in black the 2003 to 2022 mean. So you see just how significant it was, how many more wildfires there were, how much more emissions resulted from them. In 2023, it was really much greater than previous years, also greater than last year, even though last year was also pretty intense. So this slide just shows a comparison between the fire radiative power in Africa with also the carbon monoxide volume mixing ratio. So basically you see the emissions, you see the fire radiative power, and then you see also the emissions in two separate figures. So you can make a comparison with these, and you can also look at the time series. So in addition, so we've spoken about the forecast, reanalysis, emissions, also greenhouse gas information products. So we have, which are also available in the emissions data and in the forecast data and reanalysis. But this just shows you what kind of visualizations you can produce with this data. So we have animations, daily global forecast of atmospheric CO2 and methane at high resolution. And by the way, this is available at different levels of the atmosphere. It's not just 2D, static data. And we also have the greenhouse gas information in the form of activity-based emissions and flux inversions. Also, we have products on the ozone hole, so stratospheric ozone. And if you look at some of these figures, these are actually available on the CAMS website. So you can recreate these using data from WEkEO, but if you don't want to process all of this data, you can also just go onto the CAMS website, and you can monitor the state of the ozone hole through these various charts, and you can see how significant it was in any given year compared to previous years. So, and there are several animations and lots of information from the website on this. And it's not just the actual ozone hole itself. So CAMS now monitors also the chlorine radicals that break down the ozone. So that's the middle figure there. And also the so-called reservoir species that bring chlorine to the region. So that's on the right-hand side. So it's not just the ozone itself. And then finally, climate forcings. So this is also something that's available through CAMS. So this figure here just shows, you've got the methane and the ozone slightly positive. That's kind of offset by the negative aerosol climate forcings. But of course, the main driver is the carbon dioxide, which is still increasing, which is quite high and still increasing. And that really is what drives the global climate forcings. So again, you can get this data, you can analyze it, and it's all freely available through WEkEO. So that was just a very quick overview of the different data products. I'm just going to mention, given that this is a training webinar, I just want to mention also some of the learning resources that we have. So we have a lot of, so Gail mentioned the Jupyter notebooks. We've got lots of Jupyter notebooks that show how to handle this data, how to access, process, and visualize, and do different things like unit conversion and various different calculating the size of the ozone hole and all these kind of things. So they're basically workflows in Python that provide good tutorials on best practices for handling this data. We also have a lot of material from past trainings. There are some massive open online courses, and the material is still available for those. So I really recommend delving into some of this material. And here just some links to different learning resources. And I think that's pretty much the end of my presentation. So I think now there's a bit of time for questions. So I'll stop sharing my screen.
Thanks a lot, Chris, for your presentation. So it was a really nice presentation about the service, and we are going to go through the different questions we have for you. Okay, so the first question, which programming language are you using for the data modeling system? Is it Python or a different language? What about for satellite data assimilation?
Okay, so I think they're using Fortran still a lot, but I'm not sure. So this is for the actual operational modeling system, right? Yeah, I mean, I think they're using various different programming languages. I don't know exactly. I think they're still using Fortran a lot. What about for satellite data simulation? Yeah. So, I mean, I'm not involved in the operational data simulation, but yeah, I think they're using different programming languages. If you use data for a third-party app, I assume you pay to use the data. Right. So the data, all the data that we provide is, or all the data products that we provide are free. And this data can be used for third-party apps. So basically, even commercial businesses can use our data for free, and they can develop a business around that. So our data is always free. But maybe the question is, if you use data from a third-party app, I don't know. I assume you pay to use the data. So yeah, I don't know how the costing model works in terms of taking using, well, the satellite data is from Copernicus is free, so there's no cost associated with that. And in terms of other data, I think there are different agreements in place, but I think the key thing is that the data that we provide is completely free. And then how can I download all CAMS data variables? Can I download all CAMS data variables, models, etc. available in the ADS by WEkEO? Yes, you can. So I think now that there were some issues before, but I think now everything is available. So I think they're quite well synced now. Everything's on the Atmosphere data store is now also available through WEkEO. How precise, accurate, and meaningful are the results of CAMS analysis in measuring the air quality index? Right. Okay. So we do evaluate, so that there's validation and evaluation of our data. I think I'm not the one to say how good that is compared to maybe other systems. But unfortunately, Mark, my colleague, is not here today. He would normally be presenting in this presentation. But I could try and find out more concrete data if that's needed. Otherwise, if you go to the CAMS website, you can find very good information there. So yeah, there you can get good information on the data quality. I think it's pretty good. Derived from all your different surveys, do you have data on land cover and land use as an available product? So I think that's more the Copernicus land service that provides this kind of data. So yeah, it's best to get that from there.
Some of them are on WEkEO, but I think there is also more on the Copernicus land monitoring service also.
Yeah.
Okay.
Given the availability of 2D greenhouse gas data, have you ever used 3D modeling for greenhouse gas modeling as well? Okay, so when you say 3D modeling, I mean, it's already, I mean, it's even four-dimensional. So we've got, you've got latitude and longitude, you've got different layers of the atmosphere, and you've also got the time dimension. So in that sense, it's four-dimensional. So I'm not entirely sure what this question, given the availability of 2D greenhouse gas data, have you ever used 3D modeling? I mean, basically, we're doing four-dimensional modeling. So yeah. unless this person who's asking this question maybe wants to elaborate further. I'm not sure.
I will keep the question on the side just in case.
Yeah.
But yeah. Oh, okay.
Is it possible? Sorry, is it possible to download data as CSV or Excel for one or more parameters in a time series format, hourly data? Okay, so for some data, I mean, most of the data set is in grid format, which is a particular kind of WMO-defined meteorological data format, or NetCDF. So we also convert that data to NetCDF. But basically, the original data comes in grid format. But we do have Jupyter notebooks that show how to read that data and how to read it into Python object and process it further and even export it into a different format such as CSV. I don't think in CAMS, but for some of our data, for example, in C3S, when we produce the European State of the Climate, we make available the data that goes into these reports, and that's available in CSV format. But it's only a very few cases where we have the data in CSV format. In the vast majority of cases, it's in GRIB or NetCDF. But again, there are tutorials that show you how you can handle that data.
Thanks.
How involved are government agencies in the development of products for regional local cases? Okay, so we do have what's called a national collaboration program. So this is a program which involves national entities from the different countries who who develop further services based on our products, and we have an active collaboration with different national entities. So in that sense, many of them are government agencies, and they're very much involved, very much in collaboration with CAMS. So yes, we are very much involved with government agencies in the development of products for regional local cases. And you can get all the information on that from the website and from the service elements such as the NCP.
Okay.
I use ERA 5. Is this now available through WEkEO? Yes, ERA 5 is available through WEkEO. So ERA 5 is actually developed through the Copernicus climate change service, but that's also available through WEkEO. So all of the C3S, the Copernicus climate change service and the Copernicus atmosphere monitoring service data is available through WEkEO. Can CAMS forecasts be accessible through WMO services or other OGC protocols? Okay. So I think so. I think so. I know you can get so on already on places like Google Earth Engine, you can find ERA 5 data, for example, and so yeah, I think some of this data is available, maybe not all of it. Chris, you mentioned reanalysis of forecast products. Which CAMS product would you recommend for current meteorological data, past 7 days to now? Okay, so it depends so if we're talking about numerical weather prediction data, it's best to look at what ECMWF provides. So ECMWF provides meteorological data up to 10 days, up to 10 days, but also subseasonal to seasonal, decadal, and many different timescales. But if you're interested in past 7 days and meteorology, then it's best you go through the ECMWF kind of core meteorological data offering, many of which is now open. So in the past, there was, and there still is to some extent until the end of this year, a license applied to the use of that data. By the end of this year, it'll all be under an open license. So that's all accessible. However, through CAMS, many of the variables are also meteorological variables, but what CAMS focuses on is the atmospheric composition. So it's not so much the meteorology; it's more the atmospheric trace gases and aerosols, very much the composition of the atmosphere. So for climate projection, are you using CMIP6 multi-model, or which model are you using? So yeah, so that's more for the Copernicus Climate Change Service. And yes, we make available CMIP6 data, and we're using CMIP6 data also for the different kind of sectoral application data sets. But we're also using CMIP5 as well as CMIP6. So that is available and that is being used. Is fire data available in real time through WEkEO? Okay, so what we provide through the ADS is also synced with WEkEO. So yes, it's also available through WEkEO. So the fire radiative power and fire emissions data, that's available through there. What kind of use cases do you see for CAMS data most relevant for being used in the management of renewable energy production? Okay, so what kind of use cases do you see? Okay, so CAMS data is very relevant also for renewable energy. For example, the solar radiation time series is very good for kind of photovoltaic plant management and for solar energy products, but also lots of other examples. I mean, I can't list all of them right now, but there are many data sets that are definitely extremely relevant to renewable energy. And if you go onto the CAMS website, you'll also see examples of use cases. So I would suggest going there, as well as exploring the actual data that's available through WEkEO and through CAMS. I hope that was